Hello everyone, in this video I will be detailing the reagent formula, equipment, tools, and operating step for assaying gold ore using the colorimetric assay method. First, let's take a look at the written instructions. Before the experiment, prepare the reagents and tools according to my formula. Note that the concentration of the color developer must not be too high. Once prepared, store it in a brown dropper bottle wrapped with black cloth. Another important thing is to prepare a pack of polyurethane sponges. Cut the 10 mm thick polyurethane sponge into pieces of 10 by 10 by 3 mm. Once everything is ready, the first step is to crush the ore into powder. After grinding into powder, heat it over a fire until it changes color. I'll first demonstrate the operation of assaying gold ore using 30% hydrogen peroxide. I have prepared three types of ore samples. The first is a gold ore with a grade of 1.6 part per million. That is 1.6 gram per ton. The second is the ore sample we just processed. The third is an ore sample containing almost no gold, with a grade below 0.01 parts per million. Next, weigh 1 gram of the ore sample and place it in a test tube. Before weighing the ore sample, stir it evenly, as sampling will directly affect the assay result. Then add 2.5 mm of dilute hydrochloric acid to each test tube. Put on gloves. Hold the test tube with heat-resist glove, or clamp it with the test tube clamp, and heat it over the fire until it boils. After heating, add 1 mm of 30% hydrogen peroxide to each test tube in small multiple portions. I have 3 test tubes, so I add a total of 3 mm. Once the reaction is complete, heat it again over the fire and repeat the previous operation. Next, place it in cold water to cool, and at the same time, add 1.5 mm of masking agent to each test tube. Then put in a piece of 10 by 10 by 3 mm polyurethane sponge. Add a little water to each test tube, just enough to reach a quarter of the test tube. Seal it with a wooden stopper, making sure it's tight enough to prevent it from falling out during the next operation. The next step is to shake it gently like this for 5 minutes. Use a long tweezer to take out the sponge, shake off the water, put it in water to rinse, and then shake off the water again. Place it in the corresponding hole of the color comparison plate. Take a piece of paper towel to squeeze the sponge dry. Rinse the sponge with the buffer agent once. Squeeze it dry, then rinse it again with the urea solution. Next, prepare the color developer. First, draw 0.25 mm of the color developer and transfer it into a 5 mm syringe. Then dilute it to 5 mm with absolute ethanol. At this point, the color developer should be light green. If it's pale yellow, the concentration is too high. Drop the diluted color developer onto the sponge mentioned earlier, and the result can be read after about 1 minute. I have a little trick for reading the result. Wait for 10 minutes, find a place with stable light, and take a photo with your phone. Then adjust the contrast to 40 and the saturation to 40. Compare it with previous result to read the grade of the oil sample. The results I read are: the left one is about 1 part per million, the middle one is 0.3 parts per million, and the right one has almost no gold. Next, I will demonstrate how to perform the assay using 7.5% hydrogen peroxide. The first few steps are the same. After heating, add 2 ml of 7.5% hydrogen peroxide to each test tube in small multiple portions. Heat it again over the fire until it boils, and repeat the previous steps. The subsequent operations are all the same. Comparing the results, it can be seen that the two assay results are not much different. Here is a table showing the relationship between color and gray. When the gray is above 1 part per million, it shows pink. If you want to further determine the gray, you need to take half the sample and do the test again. For example, if you take 0.25 grams of sample and the assay shows a grade of 0.4 parts per million, then the grade of the original or sample is 1.6 parts per million. In addition, the nature of the mineral can also affect the color development, such as containing sulfur, arsenic, carbon, etc.